In this video 2.6 we will be looking at ratios, rates, and conversions. You should be able to say I can find ratios and rates, and I can convert units and rates. A ratio compares two numbers by division. You can write A to B that's one way to write a ratio as a form of a fraction, A to B with a colon, or A to B with the word to, T-O, in the middle. So we're comparing two numbers. A rate is a type of ratio that compares quantities measured in different units. The key here is the different units. So an example would be $30 to 4 albums. We're looking at dollars and we're working with albums. So we have two different units of measurement there. So that would be a rate. A unit rate is a rate with a denominator of 1 unit. So if we have something like 55 miles to 1 hour, where that denominator there is 1. So we can also say 55 miles per hour, that per meaning for 1 hour. You are shopping for sweaters. Store A sells 2 sweaters for $60 and store B sells 3 sweaters for $80. Which store offers the best deal? And explain. Well, when you're figuring out a better buy, you can always use a method of where you take both situations. So we have the $60 for 2. In store B, we have $80 for 3. So this is where we basically want to know where we're getting more for our dollar. And one way we can figure out a better buy is figure out, well, how much is just one sweater in both situations? How much is just one sweater? So if I do 60 divided by 2, for store B, it's $30 per sweater. In store B, if you do 80 divided by 3, you get $26.67 per sweater. So store B cheaper per sweater. So store B, because it is cheaper per sweater. You can see right here, so store B it is. A conversion factor is a ratio of two equivalent measures in different units. An example would be 1 foot is the same as 12 inches. That's an example of a conversion factor. And in your book, on page 801, if you look at that page, there are many conversion factors for you to use. So use that as a resource. What is 155 centimeters converted to meters? And I'm going to show you a couple ways you can go about doing this. If we're taking 155 centimeters and converting it, we can multiply it by that relationship between centimeters and meters. So we can look on page 801. I would hope you would also know that 1 meter is 100 centimeters. So I'm going to use that conversion factor. I'm going to take 155 centimeters and I'm going to multiply it by 1 meter to 100 centimeters. So I'm multiplying here by the conversion factor. Now the reason why I put 100 centimeters on the bottom and the meter on the top is because I want the centimeters to cancel. So whatever I'm converting from centimeters, I want to put that on the bottom. So now what happens is I have 155 times 1, which is 155, and then I'm dividing it by 100. because if I make this a rational number, that's over 1, multiply my numerators, denominators, and 155 divided by 100 would give me 1.55 meters, because this was meters here. You can see we still have the meters right here. The centimeters were canceled using that conversion factor. Another way of looking at this is I know I want to take 155 centimeters and turn it into meters, and we're going to say we don't know what it is. And I'm setting up a proportion using the conversion factor, and I'm going to put 100 centimeters on the top to match my unit on the left side of this proportion. I have 155 centimeters on the top on the left, so I'm going to put the centimeters on the right on the top, and then 1 meter on the bottom to match up the units on the bottom. Now I see relationships here in this proportion. I know that 100 divided by 100 gives me 1, which is in my denominator on the right side here. So if I take 155 divide by 100, I get x, which is 1.55 meters. So what I just did here is I showed you two different ways I converted the centimeters into meters. And here I kind of overlapped a little bit. It says the Space Needle in Seattle, Washington is 605 feet tall. About how many meters tall is the building? Use the fact that we're going to use this conversion factor, that 1 meter, so we're going from the metric system, is about 3.28 feet, which is in the customary system. So using that first method, if we have 605 feet and we want to turn it into meters, I'm going to multiply it by the conversion factor. Now with that conversion factor, if I had feet, I want to put the feet on the bottom so that they simplify to 1. So I have my feet on the bottom, the other part of the conversion factor goes on the top. That's what I'm turning it into, is meters. So this cancels. So I have this over 1. So I multiply the numerator. 605 times 1 is 605, and 1 times 3.28 is 3.28. And when we do 605 divided by 3.28, we end up with approximately 184.5 meters. Another method is using a proportion. If I know that my conversion factor, well, let's say I know I'm taking 605 feet, we'll take it this way here in the proportion, and I want to turn it into meters. On the other side of the proportion, I'm going to use that conversion factor. I'm going to put the 1 meter on the bottom to match up the units of measurement. I'm going to put the 3.28 feet on the top, once again to match up the feet. And with this one, I know that I could always cross multiply solving a proportion. I also know that 3.28 divided by 3.28 is 1. So if I do the same on the left side, 605 divided by 3.28 gives me the same answer as over on the left side here of the screen with the blue. The x would be, well, I better use the about because we're going to round here, is about 184.5 meters. A student ran 100 yards in 12 seconds. At what speed did the student run in miles per hour? So we're going from yards in seconds to miles per hour. So what we want to do is convert the yards here into miles. So if I have 100 yards and I want to turn it into miles, one way of doing that is setting up a proportion. And 1 mile, and I'm putting that on the bottom to match up the units of measurement, is 1,760 yards. So in this proportion, I know that 1,760 divided by 1,760 is 1. So I'm going to do the same on the left side here. I'm going to divide by 1,760, and 100 divided by 1,760 is going to give us 0.056, and that does continue. We're going to round to the nearest, let's say 100th. We'd get 0.06. So that's 100 yards in miles, so 0.06 of a mile. So now we know that the student ran 0.06 miles in 12 seconds. And we want to know how many miles did this student run in 1 hour. Well, there's a problem with how I set this proportion up. See, this x is going to represent miles, but if we look at the units on the bottom of the proportion, I have 12 seconds and 1 hour.
Conrad Anderson, if you are in the building, could you please contact Mr. Manning? Could you please contact Mr. Manning at 4:02? Thank you.
So I changed, sorry about that, so I changed the 1 hour into 3,600 seconds. Because we know there's 60 minutes, 60 seconds per minute, 60 times 60 gives you the 3,600 seconds. So now this proportion is ready to solve. And there's not a true, real basic math fact here that we see probably right away. One thing is we could look at that we're kind of going from 12 to 3,600. You're multiplying that because it's getting bigger. So you can look at the relationship that way, and whatever you do on the bottom, you do on the top. And so you're multiplying essentially by, it would be 300. So that's one way to look at it. And so you'd multiply the top by 300 to figure out the x. Or you can cross multiply, where you would do 3,600 times 0.06 and divide by 12. And we'll talk more about that in class. So if we have 0.06 miles times that by 300, we would get 17 miles. And that's in 3,600 seconds, which is an hour. So that'd be 17 miles per hour. Now in this problem, to get to that answer of 17 miles per hour, I used proportions. You could also, back in the beginning, use the other method where you multiply by the conversion factor. Can you say I can find ratios and rates, and I can convert units and rates? Write a summary and reflection, and be prepared with any questions in class.